Welcome to your deep dive. We'll be exploring, excerpts from Werner Heisenberg's Physics and Philosophy.
Oh, cool.
Yeah, it's a book that really dives into how modern physics, especially quantum theory, changes how we understand, like, reality and knowledge and stuff like that.
I know, I was reading it earlier, and it's so interesting how he doesn't just, explain the science, but he also, connects it to all these big philosophical questions.
Yeah, and it's a book written for, a more general audience.
Yeah.
So are you ready to, explore how modern science connects to ancient Greek thought and tackles all these big philosophical questions about the universe, truth, and what it even means to understand?
For sure.
All right, well, Heisenberg kind of starts by taking us on this tour of how quantum theory even evolved.
Right.
It all began with something that classical physics just couldn't explain:
Yeah.
heat radiation.
Yeah, so classical physics, predicted that a hot object should just release this, endless amount of energy at high frequencies.
Which obviously isn't what happens.
No, not at all.
Yeah, and that's where Max Planck comes in, right?
Yeah, back in 1900, he suggested that energy, actually exists in these, separate packets called quanta.
So it's not this continuous flow.
Yeah, it was a radical idea at the time.
It really was, like saying energy comes in these tiny prepackaged bundles.
Right, exactly.
Then Einstein took this idea even further.
Oh, yeah.
He used the idea of light quanta to explain, the photoelectric effect.
So that's how light can knock electrons off of materials.
Yeah, and that was a huge discovery. It earned him a Nobel Prize.
Oh, yeah.
But things get even more interesting when you see how this idea of energy packets or quanta really started to unravel our understanding of how the universe works.
For sure, yeah, because then we have Bohr proposing his model of the atom, right?
Yeah.
With electrons orbiting the nucleus in specific energy levels, but that still relied on these old ideas of orbit.
All right, from classical physics.
Exactly. And then comes Louis de Broglie, who adds another layer of complexity.
Oh, yeah.
With his idea of matter waves.
This is where things get really weird.
Right. If light, which we thought of as a wave, could behave like a particle, could particles like electrons also behave like waves?
Oh, wait, hold on. I need a minute to process that.
It's wild, right?
Yeah, because if everything is both a wave and a particle, doesn't that mean the universe is just way more fuzzy than we thought?
It challenged everything, everything physicists thought they knew.
Yeah.
The struggle to reconcile this wave-particle duality was huge, with scientists like Schrödinger and obviously Heisenberg really trying to make sense of it all.
And this is where we get Heisenberg's uncertainty principle.
The more precisely you know a particle's position, the less you know about its momentum, and vice versa.
So it's like a trade-off.
Yeah, think of it like trying to pin down a cloud.
Right, it's always moving and changing.
Exactly.
So we can never really know both a particle's position and its momentum with absolute certainty.
Nope.
Does that mean the universe is just inherently unpredictable at its core?
That's the heart of it. Heisenberg argues that quantum theory is about probabilities, not, definite outcomes.
So it's not like cause and effect in the way we usually think about it?
No, not really.
Okay.
This is what we now call the Copenhagen interpretation.
Which I know is controversial.
Very controversial, especially for Einstein.
Yeah, God does not play dice.
Yeah, he just, couldn't accept a universe governed by chance.
Yeah, and that's what that whole debate at the Solvay conference was about, right?
Exactly.
I can only imagine being a fly on the wall, watching Einstein challenge these, foundational ideas of quantum mechanics.
It must have been amazing.
Yeah, but what does this Copenhagen interpretation actually say about, reality? If it's all probabilities, how does anything actually happen?
Well, imagine reality as this, cloud of possibilities.
Okay.
And it's not until a measurement is made that a specific outcome emerges.
So the act of observing kind of collapses the wave function.
You got it.
Hold on. Are you saying that, the act of looking determines what we see?
Not exactly. It's not about some, mystical power of the mind or anything.
Okay, good. Because that was starting to sound a little too out there for me.
Yeah, no, the observer's role is really in defining the experiment, and which properties get measured.
Okay, so give me an example.
Heisenberg explains this with this thought experiment, where you observe an electron through a gamma ray microscope.
Okay.
And the act of observation, using those gamma rays, inevitably disturbs the electron.
Right.
And that's where the uncertainty comes in.
So it's if you try to watch a tiny hummingbird with a floodlight, you might catch a glimpse of it, but you're also going to change its flight path just by looking at it.
Exactly. That's a great analogy.
Okay, so how does causality, like the idea of cause and effect, work in a universe where things are probabilistic?
Well, Heisenberg says that causality still exists in quantum mechanics,
Okay.
but it's not the straightforward, deterministic causality of classical physics.
Like A leads to B leads to C.
Right. Instead, it's a causality based on probabilities.
Right.
For example, you can predict the likelihood of an electron appearing in a certain region,
Okay.
but you can't predict exactly where it will end up.
So it's more like a fuzzy causality.
I like, fuzzy causality.
Okay. But if quantum mechanics challenges these really fundamental ideas about reality and causality, does it also change our philosophical foundations?
That's where it gets really interesting.
Okay.
Heisenberg connects these mind-bending concepts to philosophical ideas, going all the way back to the ancient Greeks.
Okay.
And he finds some striking parallels.
Give me an example.
Well, he compares an Anaximander's idea of a primordial substance, the apron, to modern physics' idea of energy as the fundamental building block of matter.
So he's saying that modern physics is echoing these really ancient philosophical ideas.
Exactly.
But how does this fit with more recent philosophical ideas like Descartes' separation of mind and matter?
Well, that's where things get even more interesting because quantum theory challenges that strict Cartesian duality and suggests this deeper connection between, the observer and the observed.
Hold on. So are you saying that quantum mechanics might be bringing mind and matter back together?
It's a huge implication and it's a profound one.
Wow.
Heisenberg doesn't offer definitive answers,
Okay.
but he definitely opens the door to a more, holistic view of reality.
One that challenges that separation.
Exactly.
Wow, I'm starting to see how quantum theory isn't just, a revolution of physics,
Yeah.
but potentially a revolution in how we think about ourselves in the universe.
Absolutely. And it's not just about subatomic particles either.
Right.
It's the foundation of chemistry, and it has huge implications for biology and beyond.
That's incredible. So how does quantum theory explain the world of chemistry? With all its, intricate molecular structures.
Well, quantum mechanics governs how atoms and molecules behave.
Okay.
It explains, why different atoms bond together,
Right.
why some molecules are stable while others react easily, and why materials have specific properties like color, conductivity, or hardness.
So the quantum world is the hidden architect behind everything we see and touch.
Exactly. It's kind of mind-blowing when you think about it.
It really is. But what about the biggest mystery of all? Life itself.
Oh, yeah.
Can quantum mechanics help us understand how life emerged?
Well, that's a question that scientists are still grappling with.
Right.
Heisenberg acknowledged the challenges of applying quantum theory to complex systems like living organisms.
Right, because it's not just a bunch of molecules, right?
Yeah.
There's that extra layer of complexity, that emergent property of life that science just hasn't fully explained yet.
Yeah, but Heisenberg saw exciting potential in using quantum theory to, illuminate biological processes.
Right.
He suggested quantum effects could be at play in things like photosynthesis,
Oh, wow.
enzyme activity, and even in how the brain works.
So quantum mechanics could help us unravel the mystery of life itself.
Maybe. It's certainly a possibility, and it's a very active area of research.
That's so cool.
Heisenberg emphasized that understanding biology in light of quantum mechanics requires a holistic approach.
Right. Recognizing the interconnectedness of living systems.
Exactly.
Even with all we've learned, there's still so much we don't know.
Definitely.
Okay. But before we go too far down that road,
Yeah.
let's talk about something else Heisenberg brought up.
Okay.
The challenges of using language to describe, quantum reality.
Yeah.
I can imagine it's tough to translate those mathematical equations into, everyday language.
It's a real struggle, you know?
Yeah.
Heisenberg highlighted the difficulty of using classical concepts
Yeah.
like position and velocity
Right.
to describe the quantum world.
Okay.
We need a new scientific language
Yeah.
that can accurately reflect the probabilistic nature of quantum reality.
So we need new words, new concepts.
Yeah, he even suggested looking at, logic, philosophy, and even poetry for inspiration.
Poetry.
Yeah.
Wow, okay. This deep dive is getting pretty philosophical. Okay, but before we get too lost in the poetry of quantum mechanics, let's talk about how Heisenberg connects modern physics to this broader context of, human thought,
Yeah.
especially with all that happened in the 20th century.
Oh, for sure. Heisenberg lived through a period of immense upheaval with totalitarian regimes on the rise and the development of nuclear weapons.
Yeah, it was a time of great change and turmoil.
Right, and these experiences had a profound impact on his thinking.
Okay.
He saw the immense power of scientific knowledge, but
Yeah.
also, like, the ethical dilemmas that it creates.
Yeah, like the shadow of the atomic bomb.
Exactly. It's a reminder that scientific progress isn't always a simple path towards a better world.
Oh, true.
Heisenberg understood this deeply, and he argued for international collaboration
Oh, okay.
and open communication in science.
As a way to kind of build bridges between
Yeah.
cultures.
And to work toward a more peaceful future.
Collaboration and open communication, those are powerful tools,
They
especially in a world facing, such complex challenges.
Absolutely. And Heisenberg also advocated for what he called intellectual humility.
Intellectual humility, I like that. What does
Yeah.
that mean?
It's a willingness to be open to new ideas, even if they, challenge our deepest beliefs.
It's like a reminder that we should always be open to new ways of seeing the world.
Even if they kind of shake up our understanding of reality.
Exactly.
It's all about being open to new possibilities.
Okay, so what are some of the other philosophical systems that Heisenberg explored? Like, how did he connect modern physics to those ideas?
Oh, he dives into the works of philosophers like, Descartes, Locke, Berkeley, and Hume.
Wow, okay, so this is a deep dive in a lot of ways.
Yeah, and he shows how their ideas connect with the questions raised by quantum mechanics.
Like how our understanding of reality is changing.
Exactly, and how concepts like causality and determinism take on new meanings in light of quantum mechanics.
That's fascinating, but wait, didn't he also talk about the theory of relativity? Okay, we're going to need like a whole other deep dive to explore that.
We probably will, but he gives a really clear explanation of both special and general relativity.
Wow, so he covers a lot of ground.
Yeah, he shows how those theories revolutionized our understanding of space, time, gravity.
Okay, now I'm really intrigued.
Yeah, it's pretty mind-blowing stuff.
So are we ready to dive into the mind-bending world of relativity?
Let's do it.
Okay, we'll be back soon for part 2 of this deep dive.
Sounds good.
I can't wait.
Me neither.
All right, so we left off talking about how quantum mechanics challenges our understanding of reality and causality. Now, I'm ready to tackle relativity. It's a theory that, messes with our everyday ideas about space and time, right?
It really does, yeah. Heisenberg starts by explaining how Einstein even came up with these theories of relativity.
Okay.
He talks about how physicists back then were trying to detect this thing called the luminiferous ether.
No.
Luminiferous ether, it was this hypothetical substance they thought, carried light waves.
So they thought light needed some sort of medium to travel through, kind of like sound waves traveling through air.
Exactly, yeah, that was the big idea back then. But, every experiment they did to try and detect this ether failed.
Oh, wow.
Yeah, and the most famous one was this experiment called the Michelson-Morley experiment.
Okay.
And it showed that, get this, the speed of light was constant.
Regardless of what?
Regardless of the Earth's motion.
Huh. So they were expecting to see a difference in the speed of light, depending on, how the Earth was moving through this ether.
Right, but they found nothing.
Nothing.
Nope.
Wow. So that must have been a big shock.
Yeah, it really paved the way for, a totally new way of understanding the universe.
It challenged their assumptions.
Completely, and that's what led Einstein to develop his theory of special relativity, which is based on two, fundamental principles or postulates.
Okay, hit me with those postulates. I'm ready to have my mind blown.
All right, so the first one is that the laws of physics are the same for all observers who are moving at a constant speed.
Okay.
In other words, there's no absolute frame of reference.
So whether you're standing still or, cruising along at a constant speed, physics works the same way.
Exactly.
Interesting.
Now, the second postulate is where things get really wild.
Okay, give it to me.
It says that the speed of light in a vacuum is constant for all observers.
Hold on. So the speed of light is always the same, no matter what.
No matter what, doesn't matter how fast you're moving or how fast the light source is moving, the speed of light is always the same.
Okay, I think I need to sit down for this.
It's crazy, right? It goes against everything we experience in our everyday lives. Normally we think speeds just add up, right?
Right.
But Einstein showed that the speed of light, that's the limit, like a cosmic speed limit.
Nothing could go faster.
Nope, and this idea that the speed of light is always constant has some crazy consequences.
Okay, like what?
Time dilation, length contraction.
Time dilation, length contraction. Those sound like something out of Star Trek.
Yeah, they sound like science fiction, but they're real.
Okay, Break it down for me. What do those even mean?
Okay, so time dilation means that time actually slows down for objects that are moving really fast relative to a stationary observer.
So, like, if I could somehow hop on a spaceship and travel at, close to the speed of light, time would actually slow down for me compared to someone back on Earth.
Yep, you would literally age slower.
That is wild.
And the closer you get to the speed of light, the more pronounced this effect becomes.
Whoa, okay, what about this length contraction?
Length contraction means that objects actually appear shorter in the direction that they're moving when observed from a stationary frame of reference.
Okay, so not only does time slow down at high speeds, but things actually get shorter too.
Yeah.
This is blowing my mind.
I know, right? But it's this beautiful kind of weirdness. It's a testament to, the elegance and strangeness of the universe.
Right, and these aren't just theoretical ideas. They've actually been measured.
Oh, yeah, they've been confirmed experimentally tons of times. Like, those GPS satellites we use all the time?
Yeah.
They have to account for time dilation to work correctly.
Really?
Yeah, so relativity is built into the technology we use every day.
Wow, that's incredible. So relativity isn't just some, abstract theory. It's actually, woven into our world.
Exactly.
Okay, but special relativity, that was just the beginning, right?
Yeah, there's more.
Einstein went on to develop general relativity.
Which brings gravity into the picture.
Okay, I'm ready for the next level of mind-bending. How did he bring gravity into all of this?
He proposed this radical idea. Gravity isn't a force in the classical sense.
Wait, what?
Yeah, he said it's actually a curvature of space-time.
Okay, hold on. Gravity isn't a force, but I learned in school that it's the force that, pulls things together, keeps us on the ground, makes the planets orbit the sun.
I know, it's a big shift, but Einstein showed that gravity can be understood better as, a warping of the fabric of space-time itself.
So instead of thinking of the Earth being pulled toward the sun by this gravitational force, we should think of it as, rolling along a curved path in space-time that's being warped by the sun's mass.
Exactly.
That's crazy.
It is, right. Imagine a bowling ball on a trampoline.
Okay.
Creates a dip in the fabric, right? If you roll a marble across it, it will curve inward toward the bowling ball, not because it's being pulled by some mysterious force, but because the trampoline itself is warped.
Oh, I get it. So it's the shape of space-time that's dictating how things move. That's such a cool way to visualize it.
It is. And general relativity, it predicts that light will also bend around massive objects. Yeah, like stars and galaxies. And that was actually one of the first things that was confirmed through observations.
Oh, I remember reading about that. They observed the bending of starlight during a solar eclipse back in 1919.
Right.
And that was a huge deal.
Huge, yeah. It was one of the first major confirmations of Einstein's theory.
Okay, so general relativity passed the test. What other crazy things does it predict?
One of the most interesting predictions is the existence of black holes.
Black holes.
Yeah.
Regions of space-time where gravity is so intense that nothing, not even light, can escape.
Exactly.
I always found the idea of black holes so fascinating and mysterious.
Yeah.
They're like the ultimate cosmic enigma.
I know, right? Places where the laws of physics as we know them kind of break down.
Yeah, and Heisenberg emphasizes that both special and general relativity, while challenging our intuitions, have been rigorously tested and confirmed.
Yeah.
They're cornerstones of modern physics.
And have fundamentally changed how we understand the universe.
Absolutely. What a mind-blowing journey through the world of relativity. From the constancy of the speed of light to the curvature of space-time and the existence of black holes, it's amazing.
Yeah, and we've only just scratched the surface of what Heisenberg explores in his book.
Really. There's more.
Oh yeah, he goes on to explore how both quantum theory and relativity challenge our philosophical foundations.
Like how we think about reality, knowledge, the nature of the universe.
Exactly.
Okay, I'm ready to go even deeper. Bring it on.
All right, let's dive in.
All right, so we've made it through the quantum realm and tackled the mind-bending world of relativity. Phew. But there's more, right?
Oh yeah, there's always more.
I mean, how does Heisenberg tie all of this back to, the bigger picture, like human thought and our understanding of the world?
Well, he saw modern physics as this turning point.
Like a revolution in thinking.
Yeah, especially with quantum theory.
Okay.
It requires us to think differently.
Like to move beyond those old, rigid ideas.
Exactly, like the deterministic clockwork universe. That's out.
So instead of a universe that's predictable, we're dealing with one where uncertainty is, fundamental.
Yeah, and it's not just a shift in, science.
It changes how we see everything.
Yeah, Heisenberg believed this new understanding has implications for everything. Philosophy, art, ethics, politics, you name it.
It's like a chain reaction of ideas.
It is. It really is.
But, Heisenberg didn't just stick with theoretical physics.
No, he didn't.
He was really interested in how quantum theory connected to other sciences.
Like chemistry and biology.
Yeah. So let's start with chemistry. How did he see quantum theory shaping our understanding of, like, the chemical world?
Well, he emphasized that quantum mechanics is the foundation for understanding how atoms and molecules behave.
Okay.
It explains how they form bonds,
Oh, wow.
and how those bonds create all the different substances we see around us.
So all those complex molecular structures, all those electrons and atoms doing their thing, that's all quantum mechanics.
It is, yeah, pretty amazing.
It really is.
Quantum theory explains why certain atoms stick together, why some molecules are super stable while others react quickly.
And why things have different properties.
Exactly, like their color, their ability to conduct electricity, or even their melting point.
Wow. So all that complexity emerges from the quantum world.
It does, yeah.
Okay, so what about biology? Life seems so much more complex than just atoms and molecules.
It is. It's incredibly complex.
Did Heisenberg think quantum mechanics could help us understand that?
He did, yeah, but he acknowledged the challenge for sure.
Because living things aren't just a bunch of molecules stuck together.
Right. There's something more.
Like an emergent property.
Yeah, like a spark of life.
Exactly. And science hasn't fully explained that yet.
But Heisenberg saw potential in using quantum theory to, maybe shed some light on those biological processes.
Like, how does life actually work?
Yeah, he thought quantum effects might be at play in photosynthesis, for instance.
Wow.
Or, in how enzymes function, maybe even in the brain.
So maybe quantum mechanics could be the key to understanding life itself.
It's a fascinating possibility.
It really is, and I know it's an area that's still being actively researched.
Oh, absolutely.
Heisenberg really stressed that to understand biology in light of quantum mechanics, you need to take a holistic approach.
It's about seeing the whole picture, recognizing how interconnected everything is.
Yeah, and it reminds us that even with all we've learned, there's still so much out there.
So many mysteries to explore.
Okay, speaking of mysteries, Heisenberg also talked about the future of physics.
Oh, yeah, the search for a unified theory.
One that could bring quantum mechanics and general relativity together.
The so-called theory of everything.
Exactly. Did you think we'd find it?
Well, Heisenberg was a very thoughtful physicist, very cautious.
So he didn't make any grand predictions.
Not really, but he believed that such a theory would require a pretty radical shift in thinking.
Like, we'd need to come up with totally new concepts.
Maybe even invent a new language to describe reality.
Because the language we use now, it's limited by our everyday experience.
Exactly, and it might not be up to the task of, describing the universe in all its complexity.
It's almost humbling to think about how much we still don't know.
It is, and Heisenberg ends his book with a call for humility, open-mindedness, and, a willingness to embrace uncertainty as we keep exploring.
It's a good reminder that scientific discovery, it's about the journey, not just the destination.
Exactly. Asking the questions is just as important as finding the answers.
And the universe, it will always have surprises for us.
You can count on it.
Well, this has been an incredible journey.
It has.
From the quantum world to relativity to all these philosophical questions.
It's been a real deep dive.
It has, and it's challenged how we think about the universe and our place in it.
And hopefully left you with a sense of wonder.
Absolutely, a sense of wonder and a thirst to learn even more.
That's what it's all about.
Thanks for joining us for this deep dive. We'll be back soon to explore more big questions and amazing ideas.
Until then, keep exploring.
Keep those minds curious.